everyone. It's 15th of April, about midnight actually. Just out here in my lab playing. We've got three things going on here. Let me start with the Lawrence Tseung, this little simple oscillator. I'm just running off the capacitor here, and we're down to 0.545 volts. It's dropping very slowly, if at all, just sitting there. And yet the light is quite bright, as you can see, and a little LED, and I'm just measuring the voltage here. And then next I have a Tesla coil, which is run by a blocking oscillator. Also, these are all three blocking oscillators, and this one's not even plugged in. This guy, he's not turned on at the moment. If you put a test bulb there, there's nothing there, it's turned off. And over here we have this is built by Lynx, my friend Marcus, and this is very funny. This is called the crossover circuit, designed by see, Lasersaber came up with this, and I'm playing with it, and Lynx has modified it a bit. This battery is important, but I've done some measurements. The battery does seem to be charging in this circuit. We're hooked to ground on this side, which is so-called antenna, and this side is also hooked to ground, and yet that light flashes and the battery seems to be charging. Frequency is a little hard to measure. When it settles down, occasionally I get somewhere around, well, you can see it there, it's varying, but it's trying. So it's somewhere around 6 to 9 kilohertz. This little guy lighting up that yellow LED and then charging the battery. It may be a self-runner, we're looking at it, but it's certainly strange. Let's change the setting here, and you can see this is quite a funny thing. The blue is hooked to the device, and it's 5 volts per division, so there's quite a lot on there. Well, I'm not going to try to adjust that all over the place again, but just so you can see that pattern as that comes out of this little blocking oscillator circuit. And as I say, it does seem to be charging the battery, and that's what my friend Lynx noticed also. Now let's come back over here. She's run down on this, and the battery is still sitting at 0.546. Now if I touch the transistor, I don't know why that is, then the LED lights up again, very bright, as you can see, very bright, and then the voltage across the capacitor does drop, and this will continue to light up like this as long as I touch the transistor. Little and I can release it, so maybe it's temperature dependent here, opening the gate. Now these blocking oscillators are very sensitive. But anyway, I can get down to about 0.32 volts, and this LED will still light up if I'm touching the transistor. I think that it is temperature dependent, because I have to touch that for a minute and get that warmed up a little. Then if I remove my hand, it still lights for a moment. Okay, and this guy will just fire along merrily, quite independent of everything else. Now, if I put this little Tesla coil, runs off a 1.5 volt battery, because instead of having a spark gap and a neon transformer and so on, simply I'm using a little blocking oscillator here, and I credit Gary Bluer for this particular design and build. So there's nothing there, but I'm going to plug this in. Now notice what happens when I put the battery in the circuit. This light over here dims, actually. So for some reason that dims, and of course the pattern changes, off and Tesla on. So now we'll look at the Tesla coil. Let's check and make sure she's on. Yeah, she's on. I've got another coil, the twin coil to this one. So here's the primary and the secondary, and just running off a 1.5 volt battery there. Now this coil up here, it seems no matter how far I put it away, it's another secondary, but to follow that down, it's just tied into the board along the red rail. Nothing's tied into the red rail. But it works. Let's see if it works. Sure enough, way up here, and this of course is wireless. I mean, I'm just picking that up wirelessly on both sides. Yeah, so symmetrical, and it's a lot of fun. This little Tesla coil. You see that light up? Move it away, goes off, lights up. In here, I'm dropping this thing. It doesn't. Yeah, it lights up a little inside, but really likes over here. If I go down, it goes off. It likes to be up here. Lights up quite a bit. You see, very visibly. And so this is just attached to the positive rail there. All right, let's turn the Tesla coil off, and a little possible self-runner. I'm not saying it is. This is a little crossover circuit. It's another blocking oscillator, very similar in many ways to the circuit that I have been looking at for a few years. So we're trying to see if that will actually do something. So we're having a lot of fun here. I'm not claiming anything at this point. Got a little burned when I said, hey, there's some evidence for possible power coming in, energy coming in from somewhere. But no, in this case we're just talking about having some fun and taking some measurements as we go along. And of course, if you do get a self-runner, that's kind of the gold standard of this type of research. It runs by itself and charges a battery. That'd be great. So we're trying to figure out where that energy would come in from. And these different methods. Here we have wireless transmission of energy, which is a great dream of Tesla's, using Tesla coil, but driven with a blocking oscillator and running off a 1.5 volt battery. Isn't that fun? And then of course over here, the circuit. Now I'm going to be cleaning this up, and but here we have some fun. I wanted to share it with you. Thanks. Bye-bye.